On the lecture supplement, there is a section about chemical buffers that I wasn't going to include into the acid-base discussion, but so many of you all have mentioned that you're taking anatomy and physiology that I decided that it would definitely help you guys out a little bit to at least just introduce you to this idea of a pH buffer. So the whole idea of a buffer is to resist a change in pH. What I like to think of this as kind of an analogy for is that think of a sponge, right? But a sponge for protons and a sponge for hydroxides, right? And so just like a sponge, like you could, wipe up a spill so that it doesn't go all over the place, right? But the problem is at some point you're going to saturate that sponge and then it doesn't really work anymore, right? And buffers are very, very similar. They're really important in holding for instance, the human body at a really particular pH. Turns out just as little as like a zero point 0.1 change in pH of a living system, that living system is going to feel really sick. Zero point 0.2, zero point 0.3, like in a rapid change, is pretty much going to kill you. So chemical buffers, there's a whole bunch of them in the human body. We're just going to talk about one. Their whole job is to resist a change in pH, and think of them as a sponge, right? You can actually overcome these buffer systems. There used to be a really good animation. I couldn't get the animation to work, but what I did find was kind of this silly YouTube video that actually plays the animation for us. So that's what we're going to take a look at. Before we do, though, I did want to mention that probably the one that I would definitely know is this bicarbonate buffer system. The thing that makes this a true buffer, right, is the fact that we've got some sort of acid. This happens to be a weak acid. That's important for a buffer system. It has to be made up of a weak acid and then also a weak conjugate base, right? And notice that these two things, these are paired, right? That's the acid version and that's the basic version. And both of these things have to be present in order to be truly considered a buffer. What's going to happen in this animation is I'm going to add some sort of strong acid, much like you might imagine some sort of metabolic process in the body does, right? There's all kinds of different metabolic processes. Some of them release bases, some of them release acids, but we don't want the pH of the system to change. So what happens with the buffer is the buffer will have this, right? The base actually react with the proton that you're trying to add. Without that there, you would just be adding straight up protons, right? And we saw already that the pH goes crazy when you start to add just straight up protons. So this thing's whole job is kind of to gobble up protons. Turns out this guy over here, he is going to resist any changes from a basic process, right? Because he's an acid, he's going to react with a base. And one of the things you'll notice is if this guy reacts with a base, you form more of this, right? And if this guy reacts with an acid, you form more of that. So it's almost like this kind of constant back and forth that's just all about gobbling up little obnoxious H pluses and OH minuses. And that's the way that we can kind of stabilize some system at a particular pH. That silly video I was talking about, I'll put this on the lecture slides that I post so you can actually listen to this guy actually speak as opposed to me. I think he does a better job with it than I do, quite honestly. So what we have here is a buffer system, right? This is different than the buffer system you saw. This is a different kind of buffer system, but a couple of things that are the same. We still have a weak acid and its conjugate base, right? And so this animation is going to be hydrochloric acid being added to this thing. And if this was just a straight up solution without a buffer, what would happen is that H plus would immediately lower the pH of the solution. But watch what happens when I press this little button. So you can kind of imagine that initially a little bit of H plus comes in, but you'll notice that that H plus is nearly instantaneously converted into this acid version. And the thing is that we could keep going and going and going, and eventually this would completely disappear. And at that point, you're said to have overcome the buffer system, right? And that's something where if somebody overcomes the buffer systems of the body, they get really, really, really sick, right? That's called, well, it depends on what it is, but it's either an alkalosis or an acidosis condition. What we'll see now is when OH minus starts to enter the solution here, that a very similar thing happens, but instead that OH minus consumes the weak acid. right? And so keep in mind this whole thing is happening just to make sure that we don't play around with the pH. And eventually, if this thing were to go completely away, right? Every time you added an OH, at that point, it's just like adding it to a water solution, right? And so buffer, great job at holding at a really particular pH. Each one of these buffer systems holds at a different pH, by the way. It just so happens that the buffer systems in the body tend to hold us right around, 7.3 for our physiologic pH. Aware of these slides, I don't think it's a bad idea for you to download them just because it'll really help you out, I think, when you get to these chemical concepts in A&P. There's all kinds of other information that I put in here, including other buffer systems that operate in the body. Take a glance at that if you think it's important. I also included a couple of really specific to A&P kind of actions of pH chemistry in the body. And here's a really great YouTube video that I found. So I hope that helps you A&P folks out, and I will talk to you in the near future.